All right, so today we're in section 9.3, perimeters and areas of composite figures. So what is a composite figure? It is made up of triangles, squares, rectangles, semicircles, and all of the above. Other two-dimensional figures. Okay, so composite figures. All right, so if it's made up of these figures, I need to know how to calculate perimeters and areas of these figures, okay? So for the area of a triangle, does everybody remember the area of a triangle?
No.
A equals, well, good, I told you. A equals 1/2 base times height, okay? So that's the area of a triangle. And then the perimeter of a triangle, I just add the sides together. A plus B plus C, that's all it is. Area of a rectangle. Now also, I can use this formula for a square as well. Length times width, even though the sides of a square are the same, you can still just multiply them together. And then the perimeter of a rectangle. All right, so we need to know those formulas, and then we also need to remember the circle. Do you guys remember our formulas for the circle, the circumference? There's two for circumference. C equals 2 pi r for radius, or C equals pi d. And then does anybody remember the formula for the area of a circle? Can y'all say it with me? A equals pi r squared. Pi r squared. All right, so those are my my formulas for the circle. So you do need to know those also. All right, good?
Yes.
Y'all good? All right, so in example 1, I need to, hey, here's a nice word. I kind of like this word, estimate. That means I don't have to be exact, okay? So I need to estimate the perimeter and the area of this arrow, okay? Estimate the perimeter. Well, perimeter is the distance around, all right? So I'm going to count units here. So on the left side, you see where I'm kind of drawing that line? That side is 2 units, right? 2 blocks, 1, 2. All right. Can I count the top side of that rectangle? Not going to worry about the arrow yet.
Yes.
Yep. 1, 2, 3, 4, 5. Does everybody agree this one's 5 units?
Mm-hmm.
All right. So what do you think about the bottom side?
5.
5 whole units. Now we have the arrow tip. Okay. So let's look at this block right here. How much of that block is shaded? Half. Yeah, 50% good. So half. And then how much of the block in the tip is shaded? Half, half, and half. So, yes. So how many whole blocks would that be? 2. Is everybody clear on how I got 2 out of the tip of the arrow? Because 2 halves, okay, so these 2 halves right here would make up 1. All right, so I'm going to add those together for the perimeter. It equals 2 plus 5 plus 5 plus the 4 halves, which made 2 wholes. So this represents those halves. All right, y'all with me? So we just add them together, and that is 14 units. Oh, actually, that's not perimeter, that's the area. Okay, because that's the how much inside. How much inside. Okay, that's 14 units. We'll go back and do perimeter. Sorry. Okay, so we're going to stick with area for now because I really want to get into example 2 and spend some time here. Okay, example 2. This is what's going to be on your quiz and your test next week. The estimation, it's not even going to be on there. Okay, all right, so look at this figure over here, this blue figure. It should be right there on your notes. What 2 figures make up this composite figure? Jack? Triangles and semicircle. Okay, so what I'm going to do is I'm going to find the perimeter and the area using those formulas. I've identified what shapes I have here. Okay, so if I need to know the perimeter around this figure, well, this is going to be easy because I already know these two side lengths, right? So for the perimeter, the only thing I actually need to figure out is what? I'm kind of highlighting it. The semicircle. Yes, circumference. Yes. Okay, so that's going to be my focus here to start. Circumference equals, which formula are you going to use? Aiden? Is it 2 pi r or pi d? What information am I given here in this problem? Okay, so since it gives me the diameter, I'm going to use pi d. Okay, so C equals 3.14 times the diameter. See what I'm doing? I'm trying to find the circumference of the semicircle, so I just follow my formula. Anybody remember what happens if I multiply a number by 10? Yep.
To the right.
Move the decimal to the right. So what does it make it?
31.4.
31.4. I love it when that happens. I don't have to use my calculator. But this is the circumference of an entire circle. What do I have here? Semi, so I divide by 2. Divide this by 2. What's 31.4 divided by 2?
15.7.
All right. Did you guys get the same thing? 15.7? Okay. So now I have found the circumference of the semicircle. I know that this is 15.7 feet. So what do you think you need to do now to calculate? Yeah, exactly. Calculate everything. You add them all together. 15.7 plus 8 plus 6 gives me
39.2 feet.
I got 29. 29 point. Yep, 29.7 feet. No, is the perimeter around perimeter. All right. So like I said, this is really our focus today is this example. All right, the perimeter and area of a composite figure. Does everybody see how I did that? The 8 plus 6 was pretty easy, would you guys agree? But then to find the distance around the semicircle, I had to do that circumference that you learned back in 9.1. You guys remember that? All right, so how do we do on that? You following along? Okay, so now let's do the area. Remember, what two figures do I have here? Triangle, semicircle. Okay, so now I need to do area of the triangle, 1/2 base times height, to figure out how much fills in the triangle. Remember, it's area. Okay, could you plug in those numbers based on the dimensions in the figure? 1/2. Do you know what would go in for B?
8. I mean 6.
What's the base of the triangle? Times 6. And what's the height of the triangle?
8.
Times 8. Guys, you can multiply this in any order. Commutative property. Take 1/2 of 6. And then multiply. What's 1/2 of 6, guys?
3.
What's 3 times 8? 24. But is this the full area of the composite figure? No, not even close. All I found was the triangle so far. Okay, so 24 feet squared is a triangle. But now I have to do my semicircle. We did this yesterday in 9.2. You did this last night on your homework. I need to find the area of the circle. Then what would I do?
Divide it.
Divided by 2. Okay, so A equals pi r squared. Be careful on that value for r. All right, we had people last hour kind of falling into that trap of, oh, well, I plug in 10. Do I plug in 10 for r? Okay, so is 10 the radius, guys?
No.
No, what is the radius?
5.
5. So A equals pi r 5. Everybody see where I got 5 from? squared. So what's 3.14 times, what's 5 squared?
25.
Times 25, what do you get? 78.5. Okay, feet squared. But remember what we said, is this what I need to go back and add now to 24 to find my total area?
No.
No, what do I need to do to 78.5? Divide by 2, okay? Because it's a semicircle. So now my area is 39.25. Okay? So here's what I did. The area of the triangle I found, and the area of my semicircle I found, right? When I did 39.25. So what do you think I'm going to do with those two values? Add them together. So 39.25 plus 24 gives me 63.25 feet squared. All right? It's not the easiest problem we solved all year, but it's doable. All right? You did the area of the triangle, then the semicircle, and you added them together. All right, so like I said, this is really like the most important part of the lesson today. So we're going to kind of pause here. Any questions? Anything? Okay, you try. You try. Okay, you're thinking right. You're thinking on the right lines. Okay, you need to find, listen, perimeter and area. Perimeter and area. Yes. Yep. Semicircles, there's a lot of them in there. Okay, so here we go. All right. The perimeter of the figure is only made up of the semicircles. Look here. Here we go. This is the perimeter. So the square is not involved in the perimeter at all. The only thing I need to do is calculate circumference. I used pi d because 2 inches is the diameter of the semicircle. And I can also see they're all the same. Okay, so that's important too. So I don't have to do this 4 times. So C equals pi d, 3.14 times 2. Does everybody understand where I got the 2 from? That's diameter. So this is 6.28. Now, if you understand, now remember, this is circumference of a circle. But because 2 semicircles make up a circle, then I can say that 6.28 is 2 of my semicircles. Are you with me? All right. That's a circle. So then I can just multiply 6.28 times 2. 12.56. That's my perimeter. 12.56 is my perimeter. Now, if that confuses you, say, well, it's a semicircle. I was supposed to divide by 2. Okay. Divide by 2. 3.14. How many semicircles are there?
4.
Multiply it by 4. And guess what you get? 12.56. Okay? So what I'm telling you is that 4 semicircles is the same thing as 2 circles. So what I did was, I said this is 1 circle, so if I multiply it by 2, that gives me the 2 circles. All right? Same thing, either way you do it, 12.56. Okay, let's do area. This one gets a little trickier. Did y'all do the pi r squared?
Yes.
Okay. And then we also need length times width for the square. So for pi r squared, 3.14 times 1. Does everybody see where I got 1? It's the radius. If the diameter is 2, the radius is 1. What is 1 squared? 1. So then 3.14. Guys, but remember, think about this. This is the area of an entire circle. So what I'm saying is, if there are 4 semicircles, that's equivalent to how many circles? 2. So 3.14 times 2 gives me the 6.28. Again, if you have to, did anybody half it, Hadley? I think you did. What was it? Okay, so listen, Hadley halved it. She got 1.57 and multiplied by 4, and guess what she got? 6.28. Okay, now what we do is we find the area of the circle. Now, technically, area of a circle is s squared. It's the same thing as length times width. What is 2 times 2?
4.
Area of the square is 4, and we go back and add them together to get 10.28. All right. Okay. So, is this easy? No. Is it doable? Yes. And I'm very confident that the next time we do one, you'll do much better.
It's very time consuming.
It is time consuming. Okay? All right, next example. Guys, shh, we're running out of time. Guys, look up here. You have a basketball court. The center of the basketball court has a radius of 3 feet, and it's painted blue. The rest of the court is stained, and you need to stain this basketball court. Well, 1 gallon of wood stain covers 150 square feet. So how many gallons do you need? Now, this would be really simple if that little blue circle wasn't there, right? Because if the circle wasn't there, well, I just figure out the area of the basketball court and divide by 150, right? To figure out how many gallons. Well, I still kind of do that. I need to find out the area of the basketball court, length times width. Okay, so it's 84 feet long and 50 feet wide. 84 times 50, I'll just tell you, 4,200. So if 1 gallon covers 150 square feet and that blue circle wasn't there, I would just divide and be done. But I've got the blue circle. So, and I don't need stain for that. Now, if you guys are me, I'm just going to buy a little extra and be done with it. I don't, if I lose 10 or 15 bucks, I don't really care. But in this book, we are going to get very specific. So, because we're not staining the circle, we need to figure out how much we can take out of that square footage, because that little amount of circle won't be stained. Do you see what I'm doing here? Okay. What was the radius of that circle? It told me 3 feet. 3.14 times 3 squared. What's 3 squared?
9.
What's 3.14 times 9? Okay. I got 28.26. So what's happening, okay? This is the amount of space that I don't have to stain, so what am I going to do to the 4,200? Subtract it out, because I don't have to stain it. Okay? So minus the 28.26, that tells me how much is left to stain. All right? That's a total square footage. All right? And the problem tells me that it covers 150 square feet. So if I know the total square footage, I can divide by 150. Okay, now here's the catch. This is the modeling real life. This is where you have to use, you have to use your reasoning skills. When you do that division, what does that look like? It's a crazy decimal. Do the division. 4,171.74 divided by 150. Can you go up to the Home Depot counter and say, I would like, anybody do the division?
27.8116.
Yeah, 27.8116 gallons of stain, please. What are they going to say when they look at, they're going to be like,
Crazy.
excuse me?
I'm not good at that.
I'll just give you how many, and you'll be good. 28, okay? So here's where we're going to round this up to 28 gallons because we're buying it by the gallon, all right? Those decimal values don't really mean much. And don't we need to account for waste anyway? We're going to lose some of that stain. Wiping it off, lose it on the rag, you know, paintbrush if you use a paintbrush. Has anybody ever stained anything with like wood stain? So to stain it, it's like paint, but it actually soaks into the grain of the wood. So paint would cover up like really pretty grain of the wood, but stain kind of brings out those grains, so it keeps it looking really pretty. But when you stain something, you have to do everything at the same time. If you stain part of it and then stain the next part the next day, it'll always look different. So it's kind of stressful to stain something because you have to work quickly. So everything dries the same. So anyway, that's just in case you feel like staining something. Ask your parents first. All right. Okay, well, that's it for 9.3.